Graphics and Design subject. Myself Aarti Patel from LJ Institute of Engineering and Technology. This is second session of sectional orthographic projection. In this session we are going to solve the example of sectional orthographic projection. Here you can see one 3D object is given. As per given data, draw sectional front view along X direction, top view and left hand side view using first angle projection method. Here, assume this 3D figure in one box. This box cover maximum length, maximum width and maximum height of given object. Here, front view direction is given along X. So, this line indicate length, this line indicate width and this vertical line indicate height. This is front view direction. So, this is left hand side view direction and top view direction always fixed from top side. Now, from front direction, we can see length and height of the given 3D object. We cannot see width part of the given object. From side direction, we can see width and height of the given object. We cannot see length part of the given object. From top direction, we can see length and width part of the object. We cannot see height from the top direction. First, let us find out maximum length, maximum width and maximum height of this given figure. Maximum length is equal to 25 radius plus 45 plus 20 plus 25 radius is equal to 115 mm. Maximum width is equal to 25 plus 25 means total diameter 50. Maximum height is equal to 15 plus 30 is equal to 45 mm. Here you can see the arrangement of front view, top view and left hand side view according to first angle projection method. Front view draw above XY line, top view draw below XY line and left hand side view draw right side of front view. So next let us draw front view, top view and left hand side view box with reference to horizontal and vertical axis. So first draw XY axis. Above XY axis, draw front view box which cover maximum length and maximum height. So take maximum length 115 mm and maximum height 45 mm and draw front view box above XY line. Next draw top view box below XY line. Top view box which cover maximum length and maximum width. Now length is common in front view and in top view box. So take length projection from front view box and complete top view box. Here this vertical line indicate maximum width which is 50 mm. Next draw left hand side view box right side to front view. Now front view and left hand side view both are separated by x1 y1 axis. Height is common in front view and in left hand side view box and width is common in top view and left hand side view box. So take height projection from front view. Now for width projection, first draw 45-degree angle line from common intersecting point of xy and x1 y1 axis and transfer this width in left hand side view. Here the common intersecting area of these two projection which indicate here left hand side view box. Next first draw top view in top view box because from top direction we can see the true shape of circle and semicircle. So that is the easiest way of starting projection. Next draw center line of these two circle. First draw horizontal center line passing through middle point of width. Next, draw parallel to width center line. Radius is given 25 mm. So take length 25 mm on this center line and draw vertical center line which is parallel to width. Now draw another vertical center line. For this also radius is given 25 mm. So take 25 mm length on this horizontal center line and draw vertical center line which is parallel to width. From this center point, take radius 25 mm and draw semicircle. Similarly, from this center point, radius 25 mm, draw another semicircle. Next, draw two holes of this object. One hole radius is given 14 mm and another hole radius is given 11 mm. So from this center, draw 11 mm radius circle and from this center, draw 14 mm radius circle. From top direction, we cannot see height. So from these 2 points, draw 45 mm length line. Next, draw 50 mm width line. From these 2 points, draw 20 mm length line. Next, draw projection of this triangle portion. This triangle portion is known as rib. Rib is used to provide extra support. Here, the width of rib is given 10 mm and the length of rib is given 30 mm. From top direction, we cannot see height, so the projection of rib is like a rectangle strip. So, take 30 mm length and 10 mm width from this horizontal center line and complete projection of rib in top view. Next, draw front view. Take length projection from top view. From front direction, this arc will be projected as a straight line. So, draw 115 mm length line. Next, draw 45 mm height line. From front direction, this arc will be also projected as a straight line. The radius of this arc is given 25 mm and 20 mm length given. So, draw 25 plus 20 mm length line up to this projection. Next, draw 30 mm height line. Next, draw length line up to end of the box and draw 15 mm height line. Next, project rib. Now from front direction, we cannot see width. So this point will be projected here and this point will be projected here. So take length projection of rib from top view and connect these 2 points. Now here this is indicate projection of rib in front view. From front direction, we cannot see inner surface of this 2 hole. Now this hole is drilled up to throughout height and this hole is drilled up to 15 mm height. So take length projection of this 2 hole from top view and draw 11 mm radius hole dotted line up to 15 mm height and draw 14 mm radius inner surface dotted line in front view up to 45 mm height. Next, draw left hand side view. First, locate center line of left hand side view box. From left hand side view direction, this semicircular part will be projected as a rectangle strip. Height is 15 mm and width is 50 mm. So take 15 mm height projection from front view and complete rectangle strip which cover maximum width and 15 mm height. From side direction, we cannot see length. So next draw 30 mm height line from this point. Next draw 50 mm width line. Next draw 30 mm height line. Next take projection of rib in left hand side view. The width of rib is given 10 mm and the height of rib is given 30 mm. So transfer width of the rib from top view and draw rectangle strip of this rib up to 30 mm height. So this rectangle strip indicate projection of rib in left hand side view. Next project inner surface of these two hole. One is 11 mm radius hole which is drilled up to 15 mm height and another is 14 mm radius hole which is drilled up to throughout height which is 45 mm. Now transfer its width from top view and draw its hidden line for 11 mm radius hole up to 15 mm height. Next, transfer the width of 14 mm radius hole from top view and draw its hidden line up to throughout height which is 45 mm. Now here as per given data draw sectional front view. Here take section in front view. So assume vertical cutting plane which is parallel to vertical plane. By vertical cutting plane, this object divided into two parts. When we are taking section from front direction, then remove the portion between observer and cutting plane. First locate cutting plane line in top view and in left hand side view. In top view, cutting plane line is parallel to length and passing through the middle point of the width. Now how to locate cutting line, that is we already discussed in previous session. So here locate cutting plane line with arrow. Now this arrow indicate position of observer for front view. Now for front view, the direction of arrow is upward. Next, locate cutting plane line in left hand side view. So transfer this cutting line with arrow in left hand side view. Next, draw sectional front view. Now when we are taking section from front direction by taking vertical cutting plane, now these two holes are cut by vertical cutting plane. So after taking section, the inner surface of this two hole is become visible and this surface will be cut by vertical cutting plane. So draw hatching line or section line in cut surface or the surface touched by cutting plane. Here one thing always remember, we cannot take section in rib portion. In sectional view only draw visible portion of the cut object and locate section or hatching line at 45-degree angle. Distance between two section and hatching line is 2 to 3 mm and the area of hatching line which is cut by cutting plane or touched by the cutting plane. Now one thing remember in sectional orthographic projection, first draw orthographic projection of given 3D object, then consider cutting plane as per asked question and do necessary changes in particular sectional views and remaining views are not affected by cutting plane. Next locate dimensions as per given this 3D object. 30 mm height, 15 mm height, 20 mm length, 45 mm length, next 30 mm length of the rib, 10 mm width of the rib, 25 mm radius for this semicircle, 14 mm radius of this hole, 11 mm radius of this second hole. So this is the end of this session. See you soon in next coming video lecture. Thank you.